This is the second part of the Teddy Bauer-Parkhurst problem. And we'll begin with part D, where we're asked to evaluate Teddy Bauer's profit, given that they've ordered 3,000 parkas. The expected profit formula is price minus cost times the expected sales minus the cost minus the salvage value times the expected leftover inventory. In other words, it's basically the profit for the sold parkas minus the overage cost for the leftover parkas. In order to calculate expected sales and expected leftover inventory, we first need to determine the expected lost sales. So when we know that we have 3,000 parkas ordered, we can normalize that using our standard Z formula, and we get a Z value equal to 0.75. When we look that up in the standard normal loss function table, we realize that that corresponds to a value of 0.1312. We can first convert that into expected lost sales using the formula L of Z times the standard deviation. In this case, that's 0.1312 times 1,200, which is equal to expected lost sales of 157.4. Next, we can compute the expected sales, which are equal to the expected demand minus the expected lost sales. In this instance, we know that our expected demand is 2,100 less 157.4, and we get a expected sales equal to 1942.6. Finally, we can compute the expected leftover inventory, which is equal to our order quantity less our expected sales, or 3,000 less 1942.6, which is equal to 1,057.4. Now that we have all those values, we can plug them back into the formula above, and we have a price of 22, a cost of 10. Our expected sales are 1942.6, and that's minus our costs of 10, our salvage value of 0, times the expected leftover inventory of 1,057.4. When you compute that all out, you get an expected profit of $12,737. Finally, moving on to part E, where we're asked to calculate Teddy Bauer's stockout probability. That's going to be equal to 1 minus the probability given that corresponding Z. We've already determined that that Z value is 0.75, and so when we look that corresponding value up in the standard normal distribution table, we realize that it's equal to 22.7%, and that is our stockout probability for this problem.